Hello and welcome to today's webinar. In the upcoming half-past hour, we would like to present you the most frequently answered questions by the Dlubal support of the last month. First, I would like to introduce myself. My name is Jasmin Hartung. I work at Dlubal Software in the Department of Marketing and Public Relations, and I take care of all sorts of things there. Today, I'm accompanied by my two colleagues, Andreas Hörold and Markus Baumgartel, who can now introduce themselves.
My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal software company. For instance, the Dlubal website, the German and English webinars. And yeah, I will be the presenter today.
Hello, my name is Markus Baumgartel. I'm responsible for customer support and frequently asked questions on our website. And today I will help my colleagues to answer your questions during this webinar. Okay.
Thank you so much for the introduction. Now we can turn off the webcam so the attendees can see the whole screen. So before we start, I'd like to tell you that during this webinar, you can ask us questions. You can do so by using this control panel on the right side of your screen, where you can find here a tab where you can ask questions. We will try to answer them during the webinar. If we, for some reason, have too many questions and can't answer them right now, we will send you an email where we will answer them. And if you'd just like to watch the webinar for now and ask us a question after, you can send those to info@Dlubal, and then you will receive an answer shortly. So now I will hand the screen over to Andreas.
Okay, then we start with the first model and the first question. The first question is the display of member moments due to a continuously distributed load is wrong. The moment distribution should not be triangular. How can I improve this? Now you can see on the left side here, the moment distribution of the short member shows a triangular representation. For a distributed load, and that's wrong. That display is wrong. The longer member is 10 meters long, and the shorter member 2 meters long. And by default, the longest member is divided in 10 parts. Means each part is 1 meter long, and the same is then for the short member. 2 parts of 1 meter, and that's the reason why the display is triangular. How can we improve that? First solution would be to divide the longest member, or increase. Or the second possibility is to increase the value for the member divisions in the mesh settings. The mesh settings can be found under calculate and then mesh settings, or in the menu, then it is that button here and then mesh settings. Okay, and for the member, where is the default setting number of divisions for result diagrams? 10. And if I increase that, for example, to 50 and press OK and apply and calculate all again, then you can see a curve for the moment, and that display is correct. That was the solution. Okay, then we turn to the next question. My task mode, just a moment. I have to change the setting. Okay, so then next model and next question. The next question is, how can I set a contact condition between two solids? In earlier webinars, we presented also, or we showed as special objects the nodal release and the line releases. And in this webinar, I would like to introduce the surface release. Yeah, and it's also possible to create surface releases. And I would like to show that in that example. And this example shows a grommet and through which is a bolt put on that place. And the contact conditions here in this area should be defined that the surface under tension can detached from each other. So if I load the bolt here, as we defined, it should be released on that edge here. So how to do that? Well, before I do that, I would like to introduce the solids here. On the left side, you can see the navigator data, and then you can see the solids, that ring here, this part, and so on. And the solid 4, 6, and 8 should be released from the ring here. Okay. So then I create a new surface release. On the left side, I do a right click and then new surface release. At first, I assign the surface. I switch to the transparent model. So, and that's the surface between the two solids. Okay. Then next, the release type should be defined. I specify a small spring for the X and Y direction, to avoid numerical problems, and that the bolt can be slipped out from the hole. So in the Z direction, perpendicular to the surface, I define a nonlinearity fixed in negative pz. Okay, that's all. So, and then I select the solids. So I'd move it a little bit. Okay, so then number 6, number 4, and here I switch to the wireframe model. One is not correct. Where are two solids who has the same center, 8 and 1. I select 8. Okay, and now I've got 4, 6, and 8. It's also possible to define it directly here, 4, 6, 8. Okay, that's all. I apply that with OK. And after clicking OK, a note is shown informing about some missing entries, which can be correctly automatically. So, and then I select action 2. There are some surfaces that must be released. Okay. So, and then all should be fixed, and I can calculate all. So that takes some seconds. And after the calculation, we can see that the solids are detached from each other. So I move, or I display in minus Y direction, and can also do an animation. And you can see that the bolt is released from the ring. We can also check the results for the solid. So solid sigma x, yeah, in that direction here. You can see there are only compression on that side and also on that side and no tension. Yeah. And because the bolt is released from the ring. Okay, that should be all to that question. I turn back to the first model. And the next question is, unfortunately, I'm not able to move my model by the mouse. Also shifting a node to another grid point does not work anymore. How can reactivate it? Okay, what I mean is that I can't move or copy also by drag and drop. And the reason is, or you can reactivate it by a right click and then activate the drag and drop function again. Maybe that was by an accident activated, or deactivated, and now we activate it again. And then I can move the node. I move the node, for example, or I can copy that by drag and drop, and so on. Okay, that should be all to that question. We work with that model for the next question. And the next question is, how can I change a cross-section taken from the library concerning its dimensions to a specific value? So let's create a new section. I go in the navigator data for the section, and then I select new section. And I can, for example, choose a section IPE, for example, 300. Okay. So, and at the moment, the section type is standardized steel. And if I want to modify the thickness of the web or flange, or the height, or maybe you have got an older cross section that is not standardized anymore, or you have got a rusting on for the web or for the lower flange, and you would like to modify the cross section, then you have to change the section type to parametric thin walled. So then you can go to the next dialog and change the dimensions. For example, because of rusting, you've got a web only with a thickness of 5 millimeters, or it was changed, or you have got a rusting of 2 millimeters on the lower flange. If you or you have got it on the upper and lower flange, then you can change it here, or you can also change the type. If you have got different flanges, for example, you can select such a single symmetric section. And if you want to have got a rusting on the upper and lower side, for example, of 2 millimeters, then I would like to select 8.7. And then I have to modify the 300 to 296. Okay. So that's one possibility. And the other possibility, of course, is to use our section, the single or the standalone program, and then you can use that R section, cross-section, in the RFEM or RSTAB model. Okay, so then we turn to the next model and the next question. And the next question is, I would like to hide my surface results for a certain area around the 0 value. Is there any elegant solution for this in RFEM 6? Yeah, if only individual areas in a model are decisive for the design, the evaluation based on isobands may quickly become confusing. And you can avoid that with that function here in the navigator results, and then type of display, isobands, and you can check the gray zones. So, and below the item, you can select a value between 0.1% and 50% to be covered by the gray area. It is only 0.1%, 1 promille, 1%, and so on. Yeah, I think a good display solution. Okay. Then we turn to the next question and the next model. And the next question is, how can I connect as fast as possible a beam to another beam by a thin plate using the steel joints add-on? Yeah, that's quite easy. First, I have to activate the steel design add-on in the base data. So left above, have to got the base data, and it's necessary to select or to activate the steel joints add-on. And then under standards 2, you have to choose the standard and the national annex. I leave the standard national annex of the Eurocode 3. Okay. So, and then the types for steel joints is activated, and I can create a new joint by right-click, new steel joint. So, and in the main table, you can define the node to be designed. So, okay. Now all members or all the 3 members are selected now. Now we need all the members. And I can select the next step. I have to define the supported ends. I define as supported ends the end of member 2 and member 3. And member 2 and member 3 are continuous members. So that should be all. You can also define the material. I use the material that is already defined in RFEM 6 and also the section. So, and then in the components tab, we find all specification for the joint type. And with the insert components from library button, we can choose from various pre-fabricated categories. Now we've got the rigid connections here, the pinned, the truss, and the bracing. Okay, we would like to use a pinned connection, and you can see the beam to beam connections, beam to column, beam to continuous beam, column to beam, and cross joint. We select the category beam to beam. Now we won't use the cleat, but the fin plate. Also short end plate is available. So, and if I apply the template, you can see a preview here. Okay, that looks quite good. And I can apply that with OK. So then we can see also the preview here. And we can define the single parameters here. Member 1 is the connected member. Then the reference member, or the reference members in that case, are the member number 2 and number 3. That's already correct. Then the corrected member offset is parallel. That's okay. And the connected member and offset should be more than 10 millimeters. I select 70 millimeters, and you can see there's no collision or overlapping anymore. Material for the plate is okay. We use the same material, the S335. Then the thickness is 10, okay. Alignment, connected member, that's also okay. The position, you can change that from front to rear, if you want. I leave it on the front, and I enter here my -30 for the offsets, -30, and the overlap should be 90. Okay. So, okay. So that's okay. Then I have to select the diameter between M12 and M36. All diameters are available. I now select M12 and as the strength grade 4.6. Then you can define the number of bolts. How many rows, for example, 3, 2, and I select 1 row. And as spacing 35, and the other spacing is calculated automatically. The same is for the spacing vertically. I select 25, and the rest is calculated automatically as well. Then you can use or consider that the bolt and the shear plane is in treat. I deactivate it in that case. And for the weld, I leave the 3 millimeters weld. Okay, then you can go to the plausibility check if all is okay. It's all okay now, no errors found, and I can leave the dialog. And then in the table, I can turn to the steel joint design. I can, for example, double click on the ultimate limit state design situation that I can check if the steel joints add-on is activated. That's the case, and that's the case. Okay, that should be all. Only one note: objects to design, and I can run the calculation. That should take a short moment. So in the background, there's a model created, with and the members are then surfaces in the area of the connection. Yeah, I can show that later. The submodel, and that's why the calculation takes some time, but I think it's not too long. Okay. You can see the design ratios in the table. And if I, for example, double click on that line here, or I can go to that button here, design check details. There are two possibilities. Then I can see the design details with the single design checks. Here on the right side, you can see the formulas or equations from the standard, and you can see from which standard and which tab or which part the formula is. That's the design for the fasteners, that's for the plate, and that's the design for the weld. Okay. So, and when clicking here left above the colored joint icon, you can also display the results of the joint model. Now you can deactivate some parts if you only want to see the balls and so on. And if you click on the button on the left side, at the top and at the bottom, you can save a steel joint model. I already did that and would like to show you that model. So, and that's the detailed model with all the results. I disable the results that you can see the model, and you can see the different objects, for example, surface contacts, rigid links for the welds and so on. And that's the model from the background, or that's calculated in the background, and you can see the results in the original model. And that I will turn back to the original model. Just a moment. Okay. Okay, that should be all from my side. And I hand over the screen to Jasmin.
Thank you, Andreas. I will take over again. So before we come to the end of our webinar, I would like to point out to you that anytime you can book a free online appointment with our sales team. There you can get valuable insights from one of our experts, like during product demonstrations, or you can get offers for our different programs and add-ons. So lastly, I would like to show you where you can find the recording of this webinar on our website and also our upcoming webinars. For that, you go to our website, dlubal.com. You go to News and Events, Webinars. Now here you can see a list with, for example, our next webinar next week with the building model add-on. And here you can find today's webinar. Tomorrow during the day, the recording will appear around here. Down here, you can also find the presentation slides. And down here, you can find the used models. So I would like to thank Andreas for the presentation, Markus for answering the questions. And I would also like to thank every attendee for coming here today and listening to us. And I will hope to meet you next week or in another webinar again. I would like to point out that after we end the webinar, there will be a short survey where we ask a few questions to make sure that the quality of our webinars is on a high standard. And I would like to point out that during the process of the survey, the number 1 is the lowest number and the number 5 is the highest number. So I would like to wish you a good rest of the week and thank you for attending. Goodbye.